Hi all, welcome to TutySpot. In this video, let's discuss about the elimination of left recursion. Recursion is a programming concept where function solves a program by calling itself. A function which is calling or being called by itself is called recursion. This recursion is of two types. First is the left recursion and the second is right recursion. The key issue in this topic is left recursion, where a grammar form that causes infinite loops in top-down parsers must be eliminated. So, a production of grammar is said to have left recursion if the leftmost variable of its RHS is same as variable of its LHS. Means when a grammar rule immediately or indirectly refers to itself as the very first symbol on its right hand side. Consider an example, a production rule like A produces A alpha or beta is directly left recursive, where A is the non-terminal and alpha and beta are the sequence of terminals and non-terminals that do not start with A, even including zero occurrences. For building the parse tree, we have two techniques. One is the top-down and the other is bottom-up parsing. Top-down parsing builds the parse tree from the root node, that means from the start symbol, downwards to the leaf nodes, while the bottom-up parsing builds the parse tree from leaf node upwards to the root node. So the problem here in the left recursion is, if we see the top-down parser and encounter the left recursive rule, take the first one, A produces A alpha. It causes the parser to repeatedly call the same function for A without consuming any input. So it will lead to an infinite loop and stack overflow error. Like if A function is called, then again the A function will be called here. So this loop will be continuous and alpha will not be called, leading to error, as the control always moves to the function definition without executing alpha or beta. So to overcome this, let's see how to eliminate the left recursion. To use these parsers effectively, left recursive grammars must be transformed into an equivalent non-left recursive form. The general form for a direct left recursive rule is A produces A alpha or beta is to introduce a new non-terminal typically denoted as A prime. Then rewrite the rules as A produces beta A prime and A prime produces alpha A prime or epsilon, or the empty string. This transformation converts the problematic left recursion into the right recursive structure, which top-down parsers can handle effectively. Instead of left recursion, if we take right recursion, then no problem will arise. The production of grammar is said to have right recursion if the rightmost variable of its RHS is same as variable of its LHS, like A produces alpha A or beta. So if we need to call A function, firstly alpha will be executed and then A function will be called. So there will be no any problem. So let's see the left recursion. We have the grammar A produces A alpha or beta. Let's see the first tree. A produces A or alpha, and we also have A produces beta. So take beta at this A so that the first tree is produced. And in the second tree, A produces A or alpha and this A produces beta. So the derived string is beta alpha, and for the first string only beta is derived. If we want, we can produce A and alpha for A any number of times as like this tree. Then the string here produced beta alpha alpha because A produced A alpha and again this A produced A alpha and this A produced beta. So the language is said to be as beta alpha star, means alpha can be repeated any number of times. That means it can have 0 or more occurrences. But in grammar we should not have star, so we replaced it with A prime and written the grammar as A produces beta A prime, and this A prime is briefly written as A prime produces alpha A prime or epsilon. Means if we have 0 occurrences of alpha, then it is epsilon, and if we have only one alpha, then it is A prime implies alpha. If we have more occurrences of alpha, then those occurrences are included in this A prime. So this is how the grammar is derived. Now let's take an example and try to eliminate left recursion. Suppose the grammar is E produces E plus T or T, and T produces T into F or F, and F produces within the parenthesis E or ID. We already had the grammar A implies A alpha or beta, and it is rewritten as A implies beta A prime and A prime implies alpha A prime or epsilon. This A prime can also be called as A dash. So let's take the first production. E produces E plus T or T. Here we have the left recursion because the leftmost variable in the RHS is E and the variable in LHS is also E. So they both are same. So if we compare this production with our grammar, then E is A and plus T is alpha and T is beta. So now we have to rewrite this with our rules. A implies beta A dash and A dash implies alpha A dash or epsilon. So it gives A means E implies beta means T and A dash means E dash, and E dash produces alpha plus T. A dash means E dash or epsilon. Consider the second production. T implies T into F or F. Here A is T and alpha is into F and beta is F. So rewriting with our rules, A implies beta A dash and A dash implies alpha A dash or epsilon. So A means T implies beta means F and A dash means T dash, and A dash means T dash implies alpha means into F, A dash means T dash or epsilon. And again consider the third production. F produces within the parenthesis E or ID. Here we have parenthesis. So leftmost variable of RHS is not same with variable of its LHS. So it doesn't have left recursion. So the productions we got from the given grammar after eliminating the left recursion are: E produces TE dash, E dash produces plus TE dash or epsilon, T produces FT dash, T dash produces into FT dash or epsilon, and F produces within the parenthesis E or ID. Let's see another example. The grammar is S produces S0, S1, S or 0, 1. Comparing it with our grammar, A produces A alpha or beta. So A is S and alpha is 0, S, 1, S and beta is 0, 1. So rewriting with our rules, A produces beta A dash and A dash produces alpha A dash or epsilon. So A means S produces, beta means 0, 1 and A dash means S dash, and then A dash means S dash produces, alpha means 0S 1S and A dash means S dash or epsilon. So the grammar after eliminating the left recursion is S produces 0, 1 S dash and S dash produces 0 S 1 S S dash or epsilon. Let's consider another example, and the grammar is S produces within the parenthesis L or X and L produces L comma S or X. So consider S produces within the parenthesis L or X. Here we don't have left recursion, and the second grammar is L produces L comma S or X. Here compare it with our grammar. A produces A alpha or beta. So A means L and alpha means comma S and beta means X. So the production after rewriting it with our rules will be: A means L, beta means X and A dash means L dash, and again A dash means L dash, alpha means comma S and A dash means L dash or epsilon. So the grammar after eliminating left recursion is S produces within the parenthesis L or X and L produces X L dash produces comma S L dash or epsilon. Suppose if we have multiple productions, then let's see it with an example. Consider the grammar A produces A alpha 1 or A alpha 2 and so on, beta 1, beta 2 and so on. Usually we have the grammar A produces A alpha or beta, and it is rewritten as A produces beta A dash and A dash produces alpha A dash or epsilon. So using this, write the rules for above grammar as A produces beta 1 A dash or beta 2 A dash and so on like that, and A dash produces alpha 1 A dash or alpha 2 A dash and so on like that, or epsilon. Let's see another example. The grammar is E produces E plus E or E into E or A. Compare it with our grammar. A produces A alpha or beta. A is E and alpha 1 means plus E and alpha 2 means into E and beta is A. So rewriting it with our grammar rules, A means E produces, beta means A and A dash means E dash, and A dash produces alpha A dash or epsilon. So here A dash means E dash produces alpha A dash means alpha 1 plus E A dash or alpha 2 into E dash or epsilon. So the grammar after eliminating the left recursion is E produces E dash and E dash produces plus E dash or into E dash or epsilon. Let's see another example. The grammar is S produces SX or SSB or XS or A. Compare it with our grammar. A produces A alpha or beta. For S produces SX, A is S and alpha 1 is X, and for S produces SSB, alpha 2 is SB and beta 1 is XS and beta 2 is A. So rewriting it with our grammar rules, A produces beta A dash and A dash produces alpha A dash or epsilon. First, A means S produces, beta means we have XS and A dash means S dash or beta 2 means A and A dash means S dash. Next, A dash means S dash produces alpha A dash. Alpha 1 means X and A dash means S dash, or alpha 2 means SB and A dash means S dash or epsilon. So the grammar after eliminating the left recursion is S produces XS S dash or A S dash. For A produces beta 1 A dash or beta 2 A dash, and S dash produces X S dash or SB S dash or epsilon. For A dash produces alpha 1 A dash or alpha 2 A dash or epsilon. Let's see another example having indirect left recursion. The substitution of one non-terminal in another non-terminal will leads to recursion. Means a grammar is said to be having indirect left recursion when it does not have a direct left recursion. But the production rule is given in such a way that it is possible to derive a string from the given non-terminal symbol such that the leftmost symbol or the head of the derived string is the non-terminal itself. So let's see it with an example. Suppose the grammar is S produces capital A, small a or B, and A produces AC or SD or F. So we have to eliminate left recursion for this. Let's take the first production. S produces AA or B. Here the leftmost variable of RHS is not equal to LHS. So here we don't have left recursion. So the next production is A produces AC or SD or F. Here A produces AC is having immediate left recursion, but A produces SD is having indirect left recursion. In the first production we have S produces AA or B. So we can substitute that S here in this production. Then the production will become A produces AAD and A produces BD. Then the production is said to have the left recursion. So substituting S production in A, then we will have A produces AC or SD or F and A produces AC or AAD or BD or F. So we got this production in the form of A produces A alpha 1 or A alpha 2 or beta 1 beta 2 like that, where A is A and alpha 1 means C and alpha 2 means AD, beta 1 is BD and beta 2 is F. Usually for the grammar A produces A alpha or A alpha 2 or beta 1 or beta 2, we have rules. A produces beta 1 A dash or beta 2 A dash, and A dash produces alpha 1 A dash or alpha 2 A dash or epsilon. So apply these rules to this production. Then A produces beta 1 BD A dash or beta 2 F A dash, and A dash produces alpha 1 C A dash or alpha 2 AD A dash or epsilon, and A dash produces alpha 1 C A dash or alpha 2 AD A dash or epsilon. So the grammar after eliminating the left recursion is S produces A or B, and A produces BD A dash or F A dash, and A dash produces C A dash or A D A dash or epsilon. So this is all about left recursion and elimination of left recursion. So consider the grammar. A produces BA or AA or C, and B produces BD or AB or D, and eliminate the left recursion, and let me know the final grammar in the comment section. Thank you.